So starting with part A, we are working with point estimator of P1 minus P2. So we have our appropriate statistical equation thus described. And so if we take the information in the problem, we've calculated a point estimator equal to 0.03 for part A. So for part B, we're working with a 97% confidence interval for P1 minus P2. And so the correlating statistical equation is implemented. And so this scales down to Z alpha divided by 2, which is the Z-score corresponding to the desired confidence level, 97% in this case. So the Z-score for 97% confidence level is the application of Z alpha divided by 2, hence equal to 1.88 times the square root of the equation's quantity. So the confidence interval is equal to 0.03 plus or minus 0.045. So that then quantifies to confidence interval of negative 0.015 to 0.075. So now if we focus on part C, we then focus on rejection and non-rejection. The rejections, so that is the hypothesis test, H sub O, and that scales to the versus the H2. So thus the HO is the P1 equals P2 versus P1 is greater than P2. So practically this translates the rejection region lies in the right tail of the sampling distribution of P1 hat minus P2 hat, and this identifies the significance level alpha at 25%. So the critical Z value, Z alpha, is 0.67 taken from the Z table, and our answer for C is rejection region is equal to Z is greater than 0.67, and the non-rejection region is equal to Z is less than or equal to 0.67. So now moving on to part D, we have the test statistics Z, and this is an exercise in difference in proportion. So thus Z is equal to the difference in P hats 1 and 2 divided into this expression, the difference in proportion statistical equation. So our P hat is identified as the pooled proportion, and that is equal to this equation and solved. So 0.59 is our P hat, and then our Z quantifies to approximately 0.82. The value of the test statistics Z is approximately 0.82. So moving on to the last part, part E. rejecting the null hypotheses. So the calculated z-value is 0.82, and this does not fall in the rejection region, i.e. z is greater than 0.67. So therefore we do not reject the null hypothesis at a significance level of 2.5%. So the final conclusion is as follows. We cannot conclude that the proportion of successes in population 1 is significantly greater than the proportion of successes in population 2 at 25% significance level.